Okay, so we're gonna get started by going over the homework. So I have the answer key posted on D2L, and it'll show up once I grade your assignments for you to look at. But I have it here now, so you can look at yours. You can pull it up if you would like. You can't resubmit it, but you can pull it up. And if you had any difficulty with particular ones, let me know. So I'll start going over the multiple choice, and if you're confused, let me know. How's everyone's extra day of week of break? Not really. Break, like, did anyone do anything fun? Me neither. Okay, so this first one is B. And if you have questions, just like wave your arms around. 2 is B. 3 is A. 4 is A. 5 is B. 6 is C. 7 is D. 8 is C. 9 is C. 10 is A. 11 is A. 12 is B. 13 is B. 14 is A. And 15 is B. Any of those you want to go over? No, okay. So then this next part, we did the first two in class. So the first one was nominal. Second one was ordinal. The third one was nominal. The fourth one was continuous. And then number 5 was ordinal. Any questions about those? Yes?
Why is number 3 nominal?
Yeah. So these 3 numbers are categories. So if you think of area codes, like 215, 484, 610, those are all common ones around here. They're not on a scale or a range of numbers. They're just breaking you into a category. So you would be from the 215 area code, or you'd be from the 610 area code. So they're not a scale, it's just a category. So that makes it nominal. Does that make sense to everyone? I know that one was a little confusing. What else? Any other ones? Okay. Part 3. So this first one, it's a cohort study. So that's because all the participants were without the disease when the study started, and the exposure was measured prior to the outcome assessment. So the exposure was TV watching time during childhood, measured as 2 hours per day or less than 2 hours per day. The outcome was BMI, and that was 2 levels as well, the obese BMI or not obese. And then there's this happy little 2x2 table here. So I have a nice long title. You don't have to have something that in depth, but there's that. And then these are the numbers filled in from the example at the top of that page. And then this was relative risk since it was a cohort study. You always use relative risk with a cohort study and odds ratio with the other ones. So the next question. So the answer comes out to being 1.714. Did everyone get that or something rounded like really close to that? That answer? Good. Any questions on how to get there? Okay. And then just the write-up I was looking for is just explaining what that means a little bit. So it doesn't have to be word for word what I wrote, really. Then number 2 for that last part, it's a case control study. Case control. And then the exposure was the saccharin consumption. Consumed versus did not consume was the 2 levels. And then the outcome was bladder cancer. Did they get it or not? And then you fill in the table from that scenario at the top. And then we have the odds ratio calculation down here. And this all depends on how you round it. If you got 2.010 or 2.009, if you're in that range, you'll be fine. If you got like 2.9, maybe not so much. And then just a little write-up about what that means. Any questions about those? Okay. I'll grade these in the next week and put your grades up so you'll know what you got on this first test, or homework, not test. And then, like we talked about last week, part of your grade will be how well you did, how well you think you did. So I think for this next homework assignment, what I'm going to have you do is at the end, write in, I put in 5 out of 5 for effort-wise, or I put in 2 out of 5. I know most of you will give yourselves 5s, but then I'll put in how I think you did, and that way we both have some say in that part of your grade. Does that work? Sound pretty fair? Okay, I'll make sure to post that on D2L too. So this answer key will be posted on D2L. Just, you don't, it's there I think right now, but you can't click on it because I have it set so that if a few people submitted it later than 4, they couldn't see it. So that's homework 1. I think everyone submitted it early, and everyone did the discussion board, I think. I didn't answer them all, I'm very sorry, I'm working on that. But I had this assignment for all 3 of my classes, so I have like 1,000 posts to look at, which is just craziness. And then I keep getting confused, I don't know who anyone is yet, so I'm totally sorry. So that was our homework from last week. This week we're talking about vital health statistics and tables and graphs. Super fun, I know, you're so excited. So I kind of added a few things to this PowerPoint that I didn't upload yet, but for the most part these are there, and a lot of it is stuff we're not covering this week. So I will upload this updated one. I can actually do that now so you guys can just use the same thing. Hold on. Dun-dun-dun. Whoops. I just added a few things and then I put skip this slide on like 25 of them, so we'll come back to that eventually, just not today. Now where did it go? There it is. So what's exciting is this classroom lets me get on SPSS on the computer here. So that means next week when we start learning how to use it, I can actually show you how it works. Yay! The other classroom didn't, so this is good. Alright, so I just uploaded that as this bottom one. It's pretty much the same as the graphing one, so if you printed them out, it's mostly the same. There's just a few new slides. Okay. Here we go. Maybe I should get, no, that's fine. So Dr. Stacy Metz created this originally. She was the one who had this class before she left the department to go elsewhere. So I used what she had started so that someone with a PhD has put effort into these. And I just updated stuff. So these are our objectives for today, distinguishing among the different measurement scales, which we sort of started last week, and then applying some descriptive techniques to public health data. So the outcomes for today are organizing and displaying public health related data and summarizing data, and we're not using SPSS today. You can sit on the side over there too. There's going to be like no computers available, maybe 2, maybe 1. So just do your best. So this is a summary of what we're going to cover today, just very briefly, so that when you want to come back and kind of see what this lecture was about, this is where you can look real quick. So why should you summarize your data? To describe characteristics of your sample, to help illustrate your data effectively for presentations or publications, or anything else you might be doing in the field, because people like to look at pictures. And then you should also summarize it so that you can access your tables or figures so you can see it better and more clearly. Sometimes a sentence may not really work out. You can sit on the side over here. We have a very full classroom now that we're up here. So we talked about this a little bit last week. Nominal, ordinal, this is in your homework, and then the continuous, which breaks down to interval and ratio, but we didn't go too far into that. But then these are called scales of measurement. So nominal, ordinal, or continuous. If I ask you what scale of measurement it is, that's what I'm looking for. And when you know what scale of measurement you're using, that's how you can classify and analyze and present your data. Because you present data that's categorical, like nominal data, differently than you would present continuous data. So you're going to present the average weight of a population in a different way than you would present the different ethnicities in that same population. This is just showing you a beginner's guide of when you're in SPSS, you're going to have to code variables with this 1 or 2 because it doesn't like words. It gets very confused. So you're going to use a lot of numbers in SPSS. So it's just showing you how you can break those down into different categories with the values. But we'll get more into that next week. And then some examples about categorical, nominal variables. So this is a lot more information than you got last week, but it seems like pretty much everyone did okay. So there's just some more information, some more examples for you to have. And then interval is broken down. So the interval between numbers in this interval scale is equal. So that interval between them is an equal interval. There's no absolute zero. So what that means is that 0 doesn't mean that there's none of that characteristic. So if we look at weight, 0 means you have no weight. So that would not be an interval scale because if you weigh 0 pounds, you don't have a weight, which isn't real, but you kind of get it. But if you look at temperature, a temperature of 0 degrees doesn't mean that there's no temperature. It means that it's 0 degrees, or 0 degrees Celsius is not the same as 32 degrees, or is the same as 32 degrees Fahrenheit. So that's 0 degrees Celsius is an example of an interval scale because the intervals between each degree is the same. Okay. Then ratio scale, intervals are equal between the numbers. So 0 means there is none of that characteristic. So weight, height, cholesterol, if you have a 0 cholesterol level, you have none. That's not realistic either, but kind of get the idea. Then we did this last week in class, just kind of comparing how you can have the same variable measured each of the different ways. So written out for you, nice and neat in a little table. Now on to summarizing continuous variables. So this is when the variable's on a scale from some number to some other number. So measures of central tendency are how you measure continuous variables. We're going to talk more about this in a couple weeks in more detail, but just briefly, the mean, median, and mode are ways that you can measure continuous variables. Does everyone know about mean, median, and mode? I'm going to assume most of you do. Okay, so we're not going to go into too much detail about that, but that's one of the ways that you measure continuous variables. And this little graphic I like, it illustrates for this sample of people plotted on a graph. The mean for that population is here on the very far right. Then the median is in the middle of the middle line. And then the mode would be this leftmost line, which has the most number of people there. Now in this distribution here, which is the normal distribution, the mean, median, and mode are all the same because it's the normal distribution. Some other measures are the range, standard deviation, and variance. You don't need to memorize the formulas. So these are the new slides. So for those of you who came in a little bit later, I posted them to D2L, but they're just a few new things, but they're all from the textbook. They are on D2L. So this first picture is of the normal curve. So a normal curve is unimodal. That means it has one mode, which you can see here, there's only one here. Then it's symmetrical. So if you cut this in half, longwise, this left side and the right side would be the same. And then it's not peaked and it's not flat. And you'll understand what that means a few slides from now. So modality, there's 3 different types. Unimodal, which the normal curve has, but it can also look like this. Bimodal, so it can have 2 high points, or multimodal, which is 3 or more high points in that data. So it's the values with the highest frequency. And this is just showing you what it looks like when you graph that data. Symmetric, so that would be if you folded it in half, it would look the same on both sides. Then asymmetric distributions have outliers, so that would skew the shape of your distribution. So when this happens, you might decide to use the median instead of the mean because those outliers are influencing that mean to be higher than the population average. Not average, the population's most score would be. So this left one shows a positive skew. So the way I like to remember this is that if you're going to draw a circle or something, whatever side you can draw the circle on that's bigger would be the side where it's, so if you're on this side, it's positive. So if you draw a number line with 0 in the middle, and then 1 over here and -1 over here, if you have one that looks like this, you can draw a circle over here, so that's positive. If you do the same thing, and it looks like that, you can draw the circle over here. So this would be a negative distribution. Negatively skewed distribution. But they're both asymmetric. This gets confusing to a lot of people, so however you can remember it, go for it. That's just how I remember it, just drawing the little symbol on the side. So variability, this is the last part of this little section. So the amount of differences in the distribution of a variable. So this first picture here on the left is showing a peaked distribution. Because all the scores are pretty close together and the mode is in that middle. So they're all really close and that high point's in the middle with a high peak. Then over here is flat. So this kind of goes up a little, and then it stays about the same, and then goes down a little. So there's some variation, but not a lot. So what do you think an example of this peaked distribution might be? Can you think of something, some set of data that might give that sort of a distribution? So what about, go ahead.
People obtaining certain marks in a class.
Obtaining
certain marks in class, like 90% or 80% would go in the same.
Yep. So if everyone in this class gets a A- on the homework, except a few people get an A+, and a couple, maybe 1 or 2 people get a B-, then this is what the scores would look like. So that's a good example. Any other examples? Okay, what about an example of a flat one? Something that scores might be kind of all over the place.
Maybe kids that take the SATs.
So SAT scores is definitely a good one because there's some people that are going to do really well, there's some people that are going to do okay, there's some people that are going to do not so okay, and there's some people that are going to be like, and not take it, but they show up anyway and they get a score. So that kind of goes through the whole thing. Any other examples for flat? Okay. Another example of peaked might be running times. So if everyone in this classroom was to run a mile, there'd be some people like me who would like run a mile in like 20 minutes, which would be not running, it would be walking, but that's how long it would take me. There'd be some people who finish in like 4 minutes, maybe not 4. Okay, let's go with 5 because they're cool and they run fast. And then a lot of people would be in the middle. So that's an example of peaked. Does that make sense? I totally would be Jake. I'd be there, be the last one coming through. I'd be like, "Hey guys, I'm done." Okay. So then there's a whole bunch you're gonna skip. We're gonna talk about this next week. So you will use these slides, and I'll take the skip off next week. So it's all about SPSS, but we didn't get there yet. Dun, 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 dun. So go to slide 42, if that's helpful. Oh, I totally am not doing this in order. Sorry, guys. I said I was going to do vital health statistics. We're going to do that last. No, we're not, because we need to do that before we can do the other thing I was going to do. Sorry. So crafting professional tables in APA style. This is the only thing about APA style that I am super stickler for, because it's really easy to do, and we're going to learn how to do it right now, so you should be able to do it really easily. You just have to remember to do it. So a lot of times you're going to have to format your tables like this for presentations, for papers you're submitting, for assignments for classes mostly, probably. But that's why I'm teaching you this, because in the future, when you have to do it, you'll know how to do it. Okay, so here are some tips. Your title has to appear, and it should stand alone for the table. So if I'm going to put this table here about stress and pet ownership, I don't know anything about the study that was conducted, but reading this title, Table 1, Summary Characteristics in Stress and Pet Ownership Study, that's pretty descriptive. I now know what they looked at when they did their study. In general, it doesn't need to be super specific. Also, I know the total number of the sample, so n equals whatever number is the number in your sample. Your variable names, that's these things on the left in this little table over here, they should be easy to read, and they shouldn't be relying on other parts of your text. So again, we don't have context for this table, but we can say, oh, age, okay, we know what that means. Pet ownership, yes or no. That kind of clearly means that they have a pet, yes, or they don't. Then we have current stress level, so either they have no stress, there's no one who has no stress, because let's be real here, everyone is stressed out. Then low stress, moderate stress, and high stress. So you want to be descriptive in your titles, but not too long, but enough so people understand what you're saying. Oh, the other thing is you have to indent these categories for a variable the same for each time you're indenting things. I know it's annoying, but if you're going to indent, you have to do it the same way for everything in that table. Your values are in the second column. They should be centered, and your symbols, so this plus or minus sign, should match what you have in this header row up here. So this says mean plus or minus SD, which is standard deviation, or n number and percent in parentheses. So if you have this listed here and you write out the number and percent with n plus minus percent without a percent symbol, it's gonna be wrong. It won't be all wrong, because I give lots of partial credit, but it'll be not fully correct. Does that make sense? But the thing you could do is, if you don't want to distinguish between these, you can put the mean with the SD in parentheses. I do that a lot. Then you don't have to get caught up with the plus or minus symbol, because it is a pain in the butt to add to tables. Just saying. Either way is fine. Just make sure you're consistent. Decimal places have to be consistent. So here you see there's only one decimal place, but then in their percents they're only using 1. The only exception to this is if in the field standard practice is to use more than a certain amount. So say you're using these 1 decimal places that are here, but then you're measuring something else that is standardly reported with 3 decimal places. You can report that variable with 3 decimal places and the rest of them with just 1. That's the only exception. So one of the examples on D2L that I have, if you look through it, is about forced expiratory volume. I think that's how you say it. And that's standardly reported as 3 decimal places. But then the rest of the table is using only 2. It doesn't matter how many you pick, just be consistent, unless it's standardly reported with a certain amount. Your line bordering, so this is the part that people always forget to do, because you fill in the table, and then you're like, whew, I'm done, and they skip this part. This is the most important part, because it's so easy to see if it's done wrong. There's a line on the top of the table, a line underneath your heading, and then 1 line across the bottom. There's no vertical lines, and there's no vertical side lines, and there's no crossing lines in the middle of your variables. So you have to remove all of these lines that normally come up in a table, and this one, and this one, and that one. Does that make sense to everyone? Okay, I'm going to show you how to do it too, so you'll be able to know how to do it, but don't forget that because it's the easiest way to lose points, but it's also the easiest way to get points. Summarizing categorical variables. So this is nominal or ordinally measured variables. You're going to use frequency, which is the number of individuals who responded that way in that category, as well as the percent. So the percentage of people that responded that way. When we're using SPSS, it'll show up with this table that looks kind of scary right now, but the frequency, or N, is listed here for each category, as well as the percent. So it'll be really easy to do, you just have to remember to do it. And this is how you do the SPSS procedure. We'll get there next week. So types of frequencies, the number of cases, the cumulative frequency. So if I was going to do cumulative frequency for this classroom, it would, and I started up front, there would be 4, and then there's 7 of you, so that's 11 would be the first and second row, and then there's another 7, so that's 18 would be those 3 rows, and then if I had the last row over there on the side, that would be 22. So the first row is 4, then since I add the second row to that first row, it just keeps increasing. Does that make sense? Cool. Relative frequency is the percent of a particular value. So, 4 divided by 22 is way too difficult to do in my head, so I'm not going to do that, but it's the percent of a value. Valid percent is, say, one person was missing on, they didn't answer the question about weight because they don't want me to know their weight. Okay, fine. That just means that person will be removed from the valid percent, but they would still be included in the total percent. That's the difference between those two. So if you leave a question blank, you would be still in this percent category because you're still in the class, but you would not be in the valid percent of the number of people who answered that question. And then cumulative relative frequency is the percent of everyone plus the current interval. It's complicated. We're not going to talk about that. Oh, skip some more stuff. Till next week. Yay. Okay. We're not going to do that yet because we're going to go back to that table we did. I hope you didn't close it, but if you did, that's okay. And we're going to put it into APA format. So I'm going to pull up this table, and now I'm going to have you just yell out things slowly, and I will do it so it is in proper APA format. So what is something we should add to this table? A title. So what should we make our title? Oh, actually, I'm going to show you how I make my title attached to the table. So if you move it in a document, you don't have to copy and paste two things. So I click in this top row, and then I click insert above, and it makes a new row. And then I merge all of them together into one cell. You don't have to do this, but I think it makes it easier. And then I type the table title here. So table 1, what should we call this? I don't know how to spell things. Really don't know how to spell things. I don't even know where it went. Oh no! Help, help, help! I'm just kidding. There we go. GONORRHEA. Rates in PA, Middle Atlantic, and Northeast regions. So we don't know the exact sample size for this, so we don't have to include that here. What else do we have to do? What else do we have to add to the table? Let's start with that. So if I gave you this table, if you didn't come to class today, if you gave this to your friend who's not in this class, what would you need to tell them so that they understood what this is saying?
What the numbers mean, measurements.
Right.
Per 100,000.
Yep. So you can do that. You can either write underneath here per 100,000, and then you would make that smaller, and you would put it across all three of them, or all four of them. So you can do it that way. That's one option. Or you can put a little asterisk and say measured as per 100,000. Either way is fine, but you have to tell them how you're measuring it, because 73.04 means absolutely nothing to me if I don't know that that's per 100,000 people. Because it could be a percent until you get over here to 104, then that would be a little iffy. But either of those ways is fine. What else might you want to do? Say the person is not in a health field. Do you think they're going to know what this means? Or say they just don't know what this means. You may want to elaborate and say, morbidity and mortality weekly report, and then you would put you'll put two of them here since we made that the second one. Or you could put a number, or you could put a letter in raised up a little. I like this just because it's a little faster, because you just have to click two buttons instead of finding where it is on your screen. And then STD would be sexually, oh my goodness, transmitted disease region. Okay, so now we know more about what information is included in the table. What else do we need to do to make it APA format? Take the lines out. So I'm going to show you the easiest way. So you highlight everything in your table. Then you go to table design, border styles, or actually I like to use this one. I click on the little border symbol up here. There's an arrow to the right, and you click no border. Gets rid of all of them. Then we need to have one at the top of the table. Remember, the title isn't included in the APA format. So we highlight this top row of the table, not including the title, and then we put a top border and a bottom border. And then we highlight this last one and put a bottom border there. Ta-da! Can everyone do that? Does everyone think they are capable of doing that? Okay. There's also a PDF on D2L that kind of goes a little slower, step by step of what you need to click. So that's another option if you get confused later when you're working on making a table.
There's a line under the year too. That not see there?
Oh, you're right. This is not correct because this is part of our header too. So the line should actually be under there and not on the top here. Good job. I was just, no, I wasn't. I really wasn't paying attention. No, that's what it should look like. Good catch. Any questions about this? Okay. I'm going to give you a 10-minute break because we need a 10-minute break and I need to eat a snack because I'm hungry. So 10 minutes, then we'll start on graphing, which is the last thing we have to do before I go over the homework and you leave. So 10 minutes. So now we're going to talk about graphing data. So in SPSS, when we start next week with that, we'll be doing histograms, but none of the other ones. So I'm just going to talk about the other ones now so that you know kind of what they are. There's a couple questions on your homework that have to do with these two, and your book goes over it as well. So your graph has to be standalone. So you have to be able to look at the graph just like you would the tables we talked about on its own and know what it's talking about. So again, include a title and any footnotes that might help you describe what's going on in that table. You also want to include units for whatever you're measuring. So say we were measuring weight. How am I going to know if we were measuring weight in pounds or kilograms? If you don't tell me, I don't know. Even though it might be apparent based on the numbers, but maybe I have children instead of adults, so maybe not. So you have to be very explicit about what you're including in those graphs and figures and everything. So if we're using continuous variables, these first four are what you would use to display them, and then categorical variables, which are nominal or ordinal, would be either of these two, the bar chart or the pie chart. So the histogram is distribution information, and the difference between a histogram and a bar chart is a histogram, the bars are touching. In a bar chart, they're separated. And there's a couple examples, so you'll be able to see what that looks like. A frequency polygon or cumulative frequency polygon are good for comparing two or more groups on the same measure. So if you have, there's an example, we'll get to that too. Okay. So histograms for continuous variables, you can show the frequency, your horizontal axis, so this one displays your variable of interest, and then your vertical axis displays how many are in each of those groups. The areas of those should sum to 100% of your sample most of the time. We don't get into most of the time, but it should equal 100 if you add all those percentages up. And then this is the way to do it in SPSS. Again, we'll do it next week. So here's an example. So this has the title, the histogram of random sample of respondents' occupational prestige score in the 1991 U.S. General Social Survey. So here we know that there's a total of 138 participants in this study. The frequency is over here, so 0, 5, 10, 15. And then their scores. So this score looks like it ranges from 30, and then the last person got probably about an 80. Nope, lies, 75. Can't read it, it's really small. And then over here it has the mean, the standard deviation, and the number in the sample again. One thing to remember is that this frequency along the left side of your table should always start at 0 or it gets dicey because people may think it starts at 0 and it's not, so then you're all out of whack. Here's another example of a not quite so great one because histogram for BMI, okay, but where? Where did we get this? How many people? I don't know, doesn't tell me. I mean, it tells you down here, but if we didn't have this little note at the bottom, you wouldn't know anything more about this. So we want to be a little more descriptive than that in your titles. But here's, again, this would be positively skewed because there's a big space on this side, not this side. And then this is just a written description of that previous histogram for BMI. So when you're writing up a description of it in text of an article or a paper for classes, this is what a sample of what you could write so that people know what you're talking about. Frequency polygons use the same axes as a histogram, so the variable on the x-axis and on the y-axis, the frequency. You connect all of the points with lines instead of using bars, and then at the ends, the points are connected to the midpoints of the previous and succeeding intervals of 0 frequency, whatever that means. So it just means that since there's no people in this category of 16, it's connected to the table here. And there's no people in this category of 40, 54, so it's connected to this 0 axis over there. That's what that means. Fancy words to just mean it connects to the axis after there's no one in those categories. Then this is what I meant about comparing them. So this is, they're two groups measured on cholesterol level, and then the two different age groups were separated out. So the circle points were aged 25 to 34, and the triangle points were aged 55 to 64. So just comparing the two and seeing, how they differ. Cumulative frequency polygons, again, same axes. They're a little fancier, so it's cumulative. So what it does is, like what we did when I added each row to the number before for percent or for cumulative frequency, it adds. Every time you go up in systolic blood pressure in this example, the group before is added. So as we go up and up, there's more and more people because by the end, everyone's included. We're not going to use these much, and you probably won't use them that much, but that's just what that's what it's called. And then here's another example. So these are at different percentiles. So a lot of times with kids, you hear about they're in the 95th percentile for height. This is the kind of chart that they're referring to in that. So just some examples. And there's questions on here. So do men or women have a higher BMI at the 25th percentile? Men are the lighter colored one, and women are the darker colored one. So if we look to the 25 percentile and then we go up from there, who has the higher BMI? Women. Yep. And then if we go to the 75th percentile, we can't because it's not really listed very well. It's over here. Then it would be men. And then this is a description of that table as written in the article that it was pulled from. So if you're ever writing about a figure like that. This is some text you can kind of work off of. Stem and leaf, you rarely ever see these in publications because people are just like, there's a bunch of numbers and they're all over and I don't know what's going on. So this is what it looks like. It still looks pretty confusing. So the frequency for this first one is 12 because this is the stem too. So I think we're looking at age. No, we're looking at occupational prestige score. So this would be a score of 21, then 22, then 22, a lot of 22s, and then 23, because this is the first digit, and then this number over here would be, each one is the second digit. And then we have 2 in the range of 25 to 29, or we have 16, and then 10 in the range of 30 to 34, then this one's in the range of 40 to 44, 45 to 49, and so on. So that's how you read a stem and leaf plot. If you ever need to, that's how you do it. There you go. Anyone questions about this? Okay. Here's one that was actually published. So these are the intervals listed on the very left. I don't know why my mouse isn't working. Okay, there, on the left are the intervals. The number of observations in those intervals are listed here, and then the frequencies over here. So very similar to the last one, but they included the range over here instead of just putting 9, 10, 11, 12. So similar way to set up, but a little different. Box plots. So these only display a summary of your data. They're not going to tell you every single piece of information. So the box represents the middle half of the data, and the ends represent the 25th and 75th percentile. Then there's a line in the middle of the box that represents the 50th percentile, and then the whiskers extend out for outliers or other extremes that have been measured. And they're usually, if there's outliers beyond that, they're identified as circles or X's or something. So in this example, you have the box here. So this is the 50th, the 25th, and the 75th percentile. And your whiskers come out here to your low. And this is your high, sort of. And then you have these 4 that are outliers. So they would throw off this information. If they were included in this box plot, it would probably be shifted up more this way. So they exclude it, and then this is just the majority of your information's here, and those are extras that don't really fit. So it would be like, you can think about it if everyone in the class we can think about my example of running. If everyone in the class finished in 10 to 12 minutes, 6 to 12 minutes, you'd all be in that bottom part. And I would take 20 minutes, so I would be in that top outlier because I took way longer than anyone else. So that would be the outlier. Here's another example of a ventricular mass by BMI category in women. So it's just comparing those who are underweight on the far left to those who are normal, the overweight and obese. And as you can see, the 50th percentile increases as you go through those categories. And there's more outliers as you go through those categories as well. This is how they describe a box plot in text. If you ever need to do that in the future, you can base what you're writing off of this. Just don't copy it word for word. And then bar charts. So again, this is very similar to a histogram. However, there's space between each of the bars. So you can see here, these are categories instead of a range of like ages 30 to 35 with a number here. This is the northeast region, the southeast region, and then the west. And then the percent of respondents in each of those categories. So they're nominally measured on the x-axis in a bar chart. If we're talking about a histogram,
The x-axis is continuous.
Okay. So if we look at these two bar charts, this is from your textbook, which of these charts would you use if you were trying to display this information about political affiliation? I guess it depends on the situation. Let's say you are trying to be in a fair and representative of everyone, trying to describe the representation of Democrats, Republicans, and Independents. Which chart would you choose if you were trying to be a fair representative of everyone and you wanted it to be very apparent which one you would choose?
First one.
The first one. Because it shows very clearly that pretty much it's evenly spread, because it starts at 0 and then it goes up and pretty much everyone's right around 50%. Now, this other one, so say you wanted to skew it towards Democrats, that you would want to use this one, because people may not look at this number over here. They're just going to be like, whoa, there's so many more Democrats than there are Republicans right here. But that's not really true, because this data and this data are the same thing. So be careful when you're using your axes over here, because that looks way different on the right than this one does here on the left. Okay. Pie charts. Woohoo! I love pie charts. So that's why I put one in your syllabus, because I think they're pretty. Which is totally a really bad reason to use them, but that's okay. So you use this to display nominal or ordinally measured data, and the frequencies or percentages dictate the size of the slices. So it's really easy to do in Excel, because you just type in your data and press a button and it makes it for you. So this one's a pie chart which illustrates administrators' attitude towards placing nutrition in the medical school curriculum. So it just shows the breakdown of those who strongly agree, are neutral, disagree, or strongly disagree. How is that, nominal or ordinal? Ordinal, because it's ranking them in a certain order. Good job. Yay, everyone. Okay. Ooh, now we're going to go over homework 2. Yes, we're almost done. So for homework 2, I'm not going to show you the answer key, but it is available. So same thing as the last time. There's the first part is multiple choice based on stuff from your textbook. So there are 10 of those this time, and they're each worth 1 point. Then using publicly available data, this is what we did today with the Department of Health and the asthma and the CDC Wonder. They're very similar to what we did in class, but the years might be changed. Yay! And this last one is asking you to create an APA format table from this data. So what you're going to do is make a table. So when you're in Word, if you click on, I don't know if everyone knows this, so I'm going to go over it. If you go to Insert and then Table, you can make a little table. So that's how you start out the whole process. If you didn't know, that's how you do it. Okay. So you're going to make a table that summarizes this information. I'm mostly looking for the formatting of the lines and that you're consistent with how you title the top header part, and that you include a title. Then everyone doesn't have to do it the same way. Let's put it that way. So there may be differences between what you put and what's on my answer key, but I grade as if just looking at yours. So if you do it one way, but it still meets all of those criteria with the lines being correct, you have a title, you have all of the information, you will still get full credit. If you're missing those things and it's completely a mess and I have no idea what you're saying, then you might lose some credit. And I'm very, 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 very generous, especially in these first assignments, so that you kind of get used to what I'm expecting. And I might put comments like, in the future, if you do this, I will take this many points off. But I'm not right now. So, just so you are aware of what I'm looking for in the future assignments. Because the first couple I know are difficult because you don't really know how I grade. You're getting used to class. It's the beginning of the semester. It's the end of summer, I know. So, I'm very, very flexible. And then the last part is writing a summary of the table you create. So there is a guide that on D2L that shows you an example of this, as well as the couple in the PowerPoint. This one here, sorry, examining data table is this little information thing, shows you a table and then a write-up and gives you some tips here. So that's what I'm looking for in the homework. Any questions about that? Oh, the other thing with multiple choice questions on the homework, if you aren't sure of an answer, pick one and then write your reasoning either underneath it or next to your answer, whatever, and I'll take that into consideration when I'm grading. So if there's like, if you're stuck between two answers and you really are like, it really could be either of these, just explain that and I will take that into consideration when I'm grading as well. So,
Thank you.
okay, there's one more thing you have to do. Okay, this is not graded. Not graded, this next part that I'm doing right now. For me to see that I'm being clear and for me to see what you guys are actually getting. Okay? And so that I can answer any questions that you might have before your homework's due next so that you're not like, oh my gosh, I have no clue what I'm doing. Okay, so either type your answers or write them on a piece of paper and you can either print it out or email it to me or hand that in to me before you leave. These are the two questions. What are the 5 most important things from today that you learned or you think are important from today? And then if you have 1 or 2 questions that you don't have an answer to after today's class, and put your name on it just so I know that everyone did it. Or put your name separately or something. If you don't want me to know who you are, who wrote the answers. But that's all you have to do, and after you do that and give it to me, you can leave. Or you can stay and work on your homework. It's totally fine.